Hello, everyone, and welcome to the webinar on decentralized VSD solutions or Motordrives. So, first of all, I would like to thank you very much for investing your time with us today. Okay, so my name is Rafael Souza, and I am one of the sales engineer for low voltage drives and controls products here in Brazil. And I would like to introduce you to Mr. Aloysio Correa. Okay, Aloysio Correa is also one of our sales engineer here in Brazil, and he has more than 15 years of experience with low voltage solutions, and also a few of these years working with us abroad. Okay, so Aloysio's knowledge on the decentralized VSD solution is superb. So I'm sure you will learn something new today with us. All right, so guys, let's touch base on a few of the housekeeping points for this presentation. So the first one is that all the microphones will be in mute, so that we will assure that we have a good sound quality during the presentation itself. And guys, if you have any questions to make, so feel free to use our questions and answers chat, the Q&A chat you have in this module, and then you can type it in your question to us, and we have our backing us up here to get your questions responded accordingly. Okay. So point number 3, if you miss any of the important points presented here today, you will have access to a recorded version of this presentation, and this version will be available on our LinkedIn page or either on the YouTube channel as well, right? So I highly encourage you guys to access the LinkedIn page and the YouTube channel as well, because there you will find the latest news and also information about the solutions we build to suit you guys best. All right. So I think that's all I have for the housekeeping point. So moving on, I would like again I think it's time to pass it over to Mr. Aloysio. I hope you guys have a good time with us. Enjoy it.
Thank you, Rafael. Hello, everyone. Thank you so much for attending this webinar today. And for me, it's a pleasure to be here talking to you about decentralized drive solutions, which is a technology that the industry is demanding more and more nowadays due to its flexibility and features that will be also presented today in this webinar. Okay, so let's get started. I wish you a great webinar and enjoy it. So this is the agenda for today's webinar. So firstly, we are going to review some basic VSD theory just to align our understanding. Then we will be presenting a general overview about decentralized drive solutions such as typical application and a comparison with a standard central solution. Some WEG success case will be shared with you as well. And last but not least, we'll be sizing a complete geared solution, gear plus motor plus VSD, by using CAD4CAD, which is a software for sizing gear solutions applications. Before we get started with the main presentation, I would like to give you a short introduction about WEG as a company as well, just to put everyone on the same page. So WEG is a group and it's composed by 5 business units: motor, coatings, where varnishes and paints are produced, energy, transmission and distribution, and WEG automation, which is the business units that I'm working for, and it's going to be the main focus of today's webinar. So now talking a bit more about WEG automation, here we have the main product lines which are produced inside this division. So drives, which means medium voltage and low voltage variable speed drives and soft starters. Digital business, which brings connectivity and a software solution for the 4.0 industry. electric mobility, which brings solutions for trucks and buses and vessels and so on, solar applications, electric panels, low voltage and medium voltage switchboards, critical powers, which produce industrial rectifier UPS system, devices for building and infrastructure, safety devices such as relays, sensors, contactors for safety application and so on, and controls, which means motor starting device, such as molded case circuit breakers, contactor, motor protective circuit breakers, switch disconnectors, push buttons, and so on. The global presence of WEG, we are more than 33,000 employees worldwide with 48 manufacturing sites in 12 different countries, commercial operations within 36 countries, distributors and agents around 120 countries, and with sales to more than 135 countries worldwide. This is a picture of our headquarters, which is located in Brazil, Jaraguá do Sul City. It's about 700 kilometers south direction from São Paulo city. And here we have around 14,000 employees working for the different business units of WEG. Okay, so now let's move to the main topics of today's webinar. Since we are talking about VSDs, which are used to control and protect electric motors, let's also review some a basic AC induction motor equation firstly. So motor speed is defined by 120 multiplied by frequency divided by number of poles multiplied by 1 minus slip. Just keep in mind that the number of poles and the slip, this is a motor characteristic. So in order to change the motor speed, it's required to vary the frequency parameter. And this is exactly what the VSD will do. Another important equation that we need to review is the motor torque. So motor torque is given by a constant multiplied by magnet flux multiplied by rotor current, which can be considered as constant as well. We know that some applications require constant torque, and that's why it's important to give special attention to the magnet flux equation. So magnet flux is given by a constant multiplied by voltage divided by frequency. And in this case, the variable speed drive will keep this relation constant, then the magnet flux will be kept constant, and therefore the motor torque will be kept constant as well within rated conditions. Okay? So VSD, variable speed drive, also known as VFD, variable frequency drive, ASD, adjustable speed drive, AFD, adjustable frequency drive, frequency inverter, but at the end of the day, they are the same thing, and it's used basically to control the speed of an AC induction electrical motor. It's important to mention that WEG also has VSD suitable for PM motor, permanent magnet motor as well. So the working principle of a typical 6-pulse VSD, we can say that can be divided into 3 main parts mainly. So the diode bridge, the DC link or the DC bus, and the inverter unit. So firstly, the AC input voltage passes through the rectifier bridge, which is composed by 6 diodes. And in this point in here, we have a rectified voltage. However, as you can see, the rectifier voltage has ripples. And that's why the DC bus here will smooth out these ripples. And as a consequence, a DC voltage will be available at the inverter section. Now, the inverter, which is composed by 6 IGBTs, which means isolated gate bipolar transistor, will convert a DC voltage to an AC voltage by using the PWM technique, so pulse width modulation. So these IGBTs will be switching in a such way that a voltage pulse here can be controlled, and as a consequence, a variable voltage and frequency can be generated at the output of the VSD. And since I can vary the frequency at the VFD output, it's possible to vary the motor speed. Now, comparing with the first equation from the motor speed that we mentioned at the beginning, the parameter frequency can be changed. As a consequence, I'll be changing the motor speed as well. So now let's enter into the decentralized drive section. So what is a decentralized drive? So a decentralized drive is designed to be mounted directly on the motor terminals or as close as possible to the machine. And one of the main features of this type of the VFD is the high degree of protection, for example, IP66. Therefore, depending on the environment where the VSD will be installed, the presence of dust or water, in case the machine needs to be cleaned, this will not damage the drive. Here we have one example where the VFD is mounted against the wall, but at the same time near to the motor set. Here we have a VSD coupled directly to the motor terminals. And here we have a complete set composed by a gear unit, motor, plus the VSD. So what are the main benefits of a decentralized solution? So we can start here with less motor cables and no shielded cables required. So since the VSD is now installed on the motor terminals or close to the machines, the output cables is shorter in this case. And here we begin to see potential saving possibilities, considering the high cost for the shielded cables between the drive and the motor. Further to this, we are aware that when there are long cable distance between the VSD and the motor, an output filter, for example, a load reactor or a DVT filter could be required in order to reduce the voltage peaks which are delivered to the motor terminals. And again, if I can take out this component from the solution, we can further reduce the total cost of the system, and as a consequence, the control cabinet can be made smaller, or for some applications, it's also possible to remove it at all, which again turns into potential savings. It's important also to mention the lower EMC interference, considering the VCD is mounted now close to the motor, having short output cable length. So this is a very important note as well. Handle of the sensor signal at the local drive, which means less cable length for complete machine, considering the cables now are not going to the control panel. Communication and power via line topology, which is a cleaner and easy connection concept, also reducing the installation time, and installation cost money. So this is a very important note to be mentioned as well. Faster and easier installation. In this case, in case we have to do maintenance or exchange the drive if it's required. It's important to mention here as well that the VSD status is visible on the inverter itself from the LED display. And also, in case the VFD is featured with a built-in switch disconnector, it's make it an easier to do this procedure of maintenance or to exchange the drive as well. And easy expanding of existing machine. In this case, we can say that, for example, if there is no more space available in the control cabinet, this topology can be extended or expanded anytime. So, guys, these are some main benefits of the decentralized solution. Of course, we summarize it, but are very important points to be mentioned as well. So what are the most common applications for decentralized solution? So conveyors, manufacturing and distributor logistics, baggage and cargo handling, post and parcel shipment, pumps, fan, compressors, general machinery. As you can see, it's quite wide, the possibility of using this solution, by the way. So here we have a classical central solution concept. As you can see, the inverters are assembled inside the control panel, which means they are located far away from the motor. And therefore, in this case, we have long cable distance between the VSD and the motor. And as already mentioned, depending on the cable distance between the VSD and the motor, an output filter here may be required in order to avoid these voltage peaks which are delivered to the motor. So these filters can increase, of course, the total cost of the solution and make the control panel bigger. And also it will be required to increase perhaps the ventilation system to cool down the temperature inside this control panel. Further to this, as you can see in this type of installation, all the sensor, analog digitals, are going to the control panel to be read. So again, more cables are required for this kind of central topology. When we talk about the decentralized solution, now we can see a cleaner installation concept. So we have only the power and the bus cable going to the VSD. And here it's important to highlight, since the VSD is mounted directly to the motor terminals, there is no need to use expensive shielded cables, which results again in savings. And as you can see for this concept of installation, all the digital and analog signals can be read directly at the inverter. And in this case, then this data can be transferred to a bus system to the main controller. And of course, due to this concept, the control cabinet now can be made smaller. And for some application, it's also possible to remove it at all, which again turns into potential savings to customer. Here I brought to you an illustration for easy understanding a comparison between a centralized and a decentralized solution. So in the first picture, as you can see, all the inverters, filters, and other components, they are fitted, installed inside the control panel, okay? While in this second picture, the VSD is now mounted directly on the motor terminals. So further to all the potential savings possibilities that we've already talked, we can see the possibility to reduce physical space as well within the installation. So this is another potential saving that can be considered when you are using a decentralized variable speed drive concept solution. This is WEG Decentralized VSD MW500 series, which is available up to 9.2 kilowatt at 400 volts. Also, this inverter is suitable for single-phase entry at 200 volts up to 1.5 kilowatt. We have wall-mounted and motor-mounted possibilities. Protection degree IP66, suitable for indoor and outdoor application. Analog potentiometer built-in, so no need of an HMI to operate the inverter. These fins instead of fans, which makes the inverter robust and suitable to operate within harsh environments, and application that includes water, dust, and of course, avoiding downtime for maintenance, which means cost reduction, again, if you don't need to use service calls in this case. Further to this, this design allows the inverter to work up to 50 degrees on motor-mounted configuration. LED indication, which allows the user to check the status of the drive, and switch disconnector that can be offered as an optional, which provide easy and safe machine maintenance, and a remote HMI that can be offered as an optional if required as well. These are some common features for MW500. So conformal coating board for class 3C2 as a standard. So this increases the lifetime of the VFD, protecting the electronic boards against corrosive atmosphere. IP66 enclosure suitable for indoor and outdoor application. Soft PLC function built-in that brings a PLC functionality to the VSD, allowing the user to customize application through the ladder program in this case. We have the RFI filter as well for reducing the EMC levels. The black color, which increases the enclosure dissipation capacity. And it's very important to mention that all softwares related to WEG drives, they are free of cost and they are ready to be downloaded from our website. Here we have an IP66 inverter assembled directly on motor terminals. This is for a pressurized water system. This is a WEG drive system for the flip flow screening machine. As you can see here, the VSD motor have been placed in the machine structure for this application. In a food factory as well, we have a decentralized drives IP66 installed against to the wall, but close to the motor as well. Just a few examples to show to you about the possibility of using a decentralized drive. So now we are going to do an example here. We are going to size a gear solution, use the Cat4CAD software. It's important to mention that this is a free tool, and also there is an online version available from WEG website, or you can access this by using the link cat4cad.vatdrive.com. Okay, so let me get back to the main viewer here. Yes, so this is the Cat4CAD main interface. You are going to understand that's a very user-friendly tool. So from here, you are going to select your sales area. In this case, we are going to use Europe in our example. You can choose from 16 different language. In our example, we are going to use English as well. And you can start sizing the product configuration from product choice. So you have to select here our gear unit WG20 series. Later, you are going to select here gear motor WG20 with decentralized drive MW500. So this is the option we have for the complete drive system. The type of the gear also can be selected here. So as you can see, you have helical gear motors possibilities, parallel shaft gear, and helical bevel gear. In this case, in our example, we are going to consider a parallel shaft, just for example, but you could select any one of these possibilities. Okay, here we are going to input the main data from the application. So output speed, if you have this data. So we consider here 30 to 50. If you have the output torque as well available, you can consider. If you don't have at this moment, you can leave it at this. So motor power, if you have this information, we are going to consider here 1.1 kilowatt. There are other fields that can be completed here as well, okay? For the energy efficiency class, in this case, this is about the motor. I'm going to consider I3. And here, anytime you can press this button to start the selection. So the software will give you some options available already, considering the inputs you already mentioned. But here I'm going to consider some more. So if I have the motor size, perhaps I have the motor number of poles. In this case, this is the main input voltage. So you can select between single phase or three phase. We are going to consider, in this case, three phase. The motor rated frequency, we are going to consider here 50 Hertz, and you can press the select button, by the way. So as you can see here, the Cat4CAD tool gave us a lot of options, a lot of combinations. You can see here output speed that we informed from the beginning, yeah. But one of the most important points that you need to observe for writing, choosing the geared solution is the service factor of the gear. So you will understand that depending the service factor, this will be applicable for different application. In this case, we are going to consider a service factor of 1.2, which means light loads, okay? So we are going to select this field. Next. And from this screen, you start seeing the motor data. So as you can see, the selected motor here, the motor rated current is 2.4 amps, the motor power 1.1, the power supply 3-phase as we choose. And for the inverter data, you can see inverter rated output current. So the software gives it to me here two options. One, which is output current 2.6, and the second, which is 3.4. In this case, the motor rated current is 2.4. So we're going to consider 2.6. Just keep in mind that the MW500 series inverters, they are sized for heavy duty applications. So an overload capacity of 150% is already standard. So in this case, 2.6 amps, considering that the inverter is heavy duty, is enough. However, if you have a different application where a high overload is required, you could select a bigger frame size. In this case, we are going to consider 2.6. So from this screen, you still have the opportunity to do some customization into your selection. So execution type of the gear. So for example, we can select with output shaft in this case. The mounting position for the gear as well. We are going to consider M1 in this case for our example. The mounting position of the terminal box, you can also select. So as you can see, this is the position about the terminal box of the motor, and as a consequence, the position that the VSD will be assembled. In this case, I'm going to consider side 1. Here still you can do some customization for your gear. Perhaps you can change the type of lubricant and so on. For the motor as well, you still can do some customization, perhaps change the protection degree. You can perhaps include a brake or an encoder to the motor. For the inverter, here you can do also some customization. So the inverter in this case has RFI filter integrated. The plug-in module, you can select this from other different options, and this is about the number of I/Os that the inverter will have built in. So if you need extra built-in I/Os, digital analog output, or maybe some bus communication, then you can select from this field. Okay, brake chopper for the VSD in this case is already included. And you have options here that you can select. You can include, for example, the disconnect switch or an external HMI. And in case you select the external HMI, you have also the possibility to buy a cable to connect between the HMI and the drive sizing, considering the size you want. Okay, so once you have done all the customization for your gear solution, then you can see from here the data sheet, the complete data sheet for the geared solution. So for example, you can copy as well this data. You can paste this data in a Word format template. You can make some additions if required, or you can simply press this button and generate a complete data sheet for the solution you sized. So the data sheet of the complete geared solution looks like this. So here you're going to have the gear data that you have input the data. So output speed as we input since the beginning, the number of stage of this gear, the color, the dimension, and so on. You are going to get also the motor data, the motor that we selected, in this case, 1.1 kilowatt, the rated speed of this motor, 4 poles machine, torques, the rated current as informed as well in the software during our selection, the certifications for these motors. And here at the end, at the bottom, you get the Frix inverter data as your selection. So as we selected here, a 1.1 inverter at constant load, the supply voltage for this inverter three-phase at 400 volts. These are the tolerance. You can see data about the humidity, the maximum altitude these drives can be installed, protection of degrees, the certifications, so on, dimensions. Here you get the information about the plug-in module that we selected, where you can see the analog input, the digital inputs, the bus system, which will be integrated to this card and so on. And also in the same data sheet, you can download the 3D model step. So you can simply take this 3D model step and you can save it in your machine and you can upload to the other software to do modifications, so on. You have here also access to the dimension drawings. So the complete set, the gear, the motor, the drives. And an additional features we have here as well is the 3D drawings also available from this datasheet. So you can have an idea about the complete set to have an idea how it's gonna look and to be. Also, here you have some tools. For example, if you want to take some measurements of these components, also it's all available from this tool, from this data sheet. So these are some new implementations, by the way, that we have now with Cat4Cat tool. Again, this is a free software which is available from WEG website. So you can use this as your convenience. Okay. So, ladies and gentlemen, with this, I conclude this presentation. Thank you again for your time. It was a pleasure to be here with you today. So this live is going to be finished now, but we are going to keep the chat open and our team will be glad to answer all your questions. Thank you again. Keep safe and see you next time.